Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. We are picking up where we left off last time. We started writing a bunch of code in terms of loading up textures from our image assets. So this time we're going to pick up where that left off and continue on with getting some of that stuff hooked up, and probably we're going to have to make a bunch of changes throughout the code base also to update to this new API. But before we jump into that stuff, I want to just take a quick second and thank all of the supporters listed here, starting with our elite partners, who is Javier Alazaron. That is the highest tier of subscription over on YouTube memberships / Patreon, followed by our partners, Gorbolis Inc. and Matt Oscard. That is the next tier of subscription over there on YouTube memberships and Patreon, followed by, finally, our supporters, who are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps offset the cost of running this channel, things like hosting fees, software licenses, assets, things like that. And of course, I would be remiss if I did not mention all of you viewers who are catching us live here, either on the YouTube side or the Twitch side, or if you're just catching the VOD after the fact. Thank you guys very much for being here. It means a lot to me, and I'm glad to have you guys here. Without you guys, this channel, thus this project, would not exist. So thank you all for being here. All right. Let's see. Lexi over there on the Twitch side, how's it going? Let's see. Zamboni, thank you for the follow. Appreciate that. Welcome. All right. So, what we are doing now, and I've actually done a little bit of work offline right before the stream started, just to kind of figure out how we kind of want to transition all of our code from this texture handler here to our actual texture system, right? Because we're going to eliminate this guy and go this route instead. So a lot of the logic seems like it might be sort of copied over, but it's really not. So what we have here is the first sort of version of this. So this is probably going to wind up being extracted into a few different functions. And parameterized a little bit. But I just kind of wanted to lay out sort of the process of things that needs to happen here when we go ahead and acquire a texture. So we did talk a little bit last night about how texture acquisition should work. So we have essentially the image asset name is used when we go ahead and request a texture. That is one of the entry points, one of many. And it returns a pointer to a texture. So this pointer to the texture may or may not be loaded at the time, right? And so the first thing we do is we go ahead and create a k-name out of the string, and this k-name is wound up using. Let me rephrase that. The k-name winds up being used as the name of the texture as well. So the image asset name becomes also the texture name by default. If we don't want that, then we need to use one of the more advanced methods, or the extended methods, or the option methods, whatever we want to call them, to load the texture, right? So this is default behavior. So we start off with a null pointer for the texture, and then we go ahead and we do a quick search using a binary search tree that we have set up in the state pointers, the texture systems pointer, state pointer rather. And so that is just something I added right here. We should probably go over this first, I suppose, and then jump back to that code. So we have a binary search tree that functions as the texture name lookup. So if you need to look up a texture by name, this is the way we do it. So the key of this binary search tree is the name, and the value of that is a U32 index into this texture array. This one right here. So this is just a flat array of textures, and it becomes the configured max textures size. We'll go over that in a second. And then we also have reference counts. So that's an array that aligns with textures. And then we also have auto releases, which is another array that aligns with textures, right? So we have this sort of, I guess you could call it destructive arrays, but it's also got other stuff in it, right? And so all of these three will be the same number of elements, and we index into that by the texture ID. And so that is how textures are going to be stored in the system. Now, if we jump down here, ignore the errors because we've got some more stuff to fix. But in initialize, we've added some new stuff. So all of this stuff here is the new stuff. So we have our array setups here. So those are based off the max texture count in our typed config. And then we loop through those and basically invalidate all the entries. Since our allocation automatically zeroes our memory for us, the reference count starts as 0, and the auto release essentially becomes false, since that memory is zeroed out when we create it, right? So really, the only thing that we have to change from that default zeroed memory is the ID of each texture within that array. We just need to set that to invalid ID to mark that particular texture slot as free, right? So that's just where we do that in a big loop. And then whenever we unload a texture, that same thing is going to happen. We'll just mark that as invalid ID along with all the other stuff we have to do. Other than that, instead of keeping a pointer to the resource system, we keep a pointer to the asset system state. And that is pretty much it in terms of initialization, right? So we have, let's see. Here we go. All right. So as I mentioned before, the first thing that we do whenever we have a texture acquire call made is we convert the name to a k name, right? We convert that string to a k name and do a binary search find in our lookup table or our lookup tree by that name. If that returns a result, then that means that the texture has already been created and is probably already loaded because that's usually pretty quick. And so all we need to do there is basically say t is, we set t to the address of the texture, the address of the textures array sub index, right? And index is that node's value, the U32, right? So we just do a quick check to make sure that the ID and the index match. So the ID of the texture that we pulled up, we just want to make sure that that matches the index. If it doesn't, we bleat about it and return null pointer. We just do a quick trace here just to, sort of spit out the texture name saying, hey, this already exists, we're just returning it. We'll probably eliminate this after we do some testing. And then we go ahead and we increment the reference count on that, right? So we, again, reference that by index. And at this point, we won't have to change the auto release because that's only ever changed the first time we actually acquire a texture. And at this point, we could just return t, right? So if it already exists, essentially all we do is look up that node, increase its reference count, and then return t, right? So pretty straightforward stuff. We've done this in other systems before. That is basically the way that works. Next, we've got a fix me here. So what I've done here is I've actually set up a synchronous version of this function first, just to kind of figure out the lay of the land and how all of this stuff needs to procedurally happen in order. And then we can go ahead and split some of this stuff out into functions and go ahead and set up the async version of this as well. Before we do that, though, let me just catch up on some comments. Let's see. That's some hardcore stuff. Oh, looks like AutoMod got you, and it timed out. I didn't go ahead and approve that quickly enough, Zambon. First time chatter, welcome. Let's see. Vulcan C is my wet dream, but I don't know either one. Fair enough. Fair enough. Yeah, sorry, your message got caught by the AutoMod there. It apparently did not like the term wet dream. I get it, and I don't get it, I suppose. Anyway, so welcome, by the way. All right. Scyful over there on the YouTube side. Hello, how's it going? Good to see you. All right. So the next step of this is if we don't have a texture that already exists in our texture cache, then that means we need to go ahead and load it, right? And loading a texture starts with getting the asset off disk first. So that is the very first thing that we do. We call our new asset system request image sync. In this case, again, we are going to be doing an async version of this as well. And so what we're going to do here is we essentially make that asset request using the image asset name, and then we're passing false here, which is actually the flip Y property that we talked about. So we do need to actually discuss what we're going to do with flip Y before we continue too much further. Because I have a couple of thoughts on that. I just haven't made sort of a decision on how that should work. But anyways, so we're doing the synchronous version of that so we can immediately check to see if we got an asset back. If we did not, then we go ahead and bleat about it and go to a label that we have set up called texture acquire cleanup. So we will come back to that in just a minute. I should mention that we have a Boolean up here that indicates success that defaults to false. And so the only place that is actually changed is if we complete all of these other steps, then it gets set right here, right before that cleanup, right? So only if we get through all of those steps and we don't fail, just success equal true gets set. All right. So once we've done that and we have the asset, then the next thing that we need to do is we need to pick a free slot in the texture cache, right? So we loop through all of that, look for a texture with invalid ID as its ID, and then we use that, right? So we set T to the state textures sub I, the address of that. We set the texture ID to I because that is the ID, right? So that's what will make this test fail in the future, and other, free/occupied tests succeed correctly, right? And then we go ahead and break. And so since we're setting T here, we can also use that as sort of a found flag, saying, if T never got set, then that means that we reached the end of the array without having done this bit in the middle, which means that our texture cache is full and has no more empty slots, right? And at that point, we should probably just increase the configuration's max texture count. Now, I happen to know off the top of my head that we have that set to 65,536, so I don't think we're ever going to hit that situation. But it is there as a safeguard. So again, if that fails, we bleat about it and then go to the texture acquire cleanup. Next, we go ahead and we insert an entry into the lookup tree. So in this case, we do U64BST insert. And so we pass the table, obviously, and then we pass the name as the key and val as the value, and that sets the U32 property of that union to TID, or the texture's ID that we set previously up here. And so the other thing that we do is if our state pointer does not have a texture name lookup, then that means that this new node that was created is the root of that binary search tree. And so we just need to check to see if that doesn't exist. If it does not exist, we set that to new node, and that essentially becomes the root, right? So again, this is kind of stuff we've seen in other places in the engine. We go ahead and set some default properties here. So we default format to RGBA8, right? So 8 bits, or 8 bits per channel. We default to a texture type of 2D, and we default to an array size of 1, right? We also default auto release to true. So we want to make sure to set auto releases sub TID to true, and then texture reference counts sub TID we set to 1. Since this is a new entry, that means we have one reference, right? Because we're acquiring it for the first time. So we go ahead and set that reference count to 1. All right, so the next thing that we do is we call out to the renderer and we say, okay, well, we've got all this information about the asset, right? So we need to acquire texture resources for this, and this is the synchronous operation. And so we pass a whole bunch of properties here to the renderer to tell it a little bit of information about what kind of texture it is. This is all stuff we've seen before, so I'm not going to go through it in great detail, but we basically give it a name for debug purposes, the type of texture, the width and height, the number of channels, which we can figure out from the format, the number of MIP levels, the array size, flags if any exist. None exist by default. And then a pointer to the texture's renderer texture handle. So this is what stores a handle to the renderer API specific texture resources. So the Vulkan resources, the DirectX resources, or the Metal resources internal to that renderer backend system. So we save the result of that off to acquisition result. We verify that here. Again, if it fails, we bleat about it and do a go to, right? Same thing with texture write data, right? So texture write data, we have an offset here that is always going to be 0 when handling a single layered texture, right? Just a regular texture 2D. We don't need to offset in memory anywhere. It's just going to start at the very beginning. So we just zero that out. We technically could have just passed 0 here, right? But this is a little bit more explicit in explaining what that is, right? We put just a little note here describing how that works. Essentially, if you have a layered texture, you may need to write that data at an offset within that texture's buffer, offset by a number of bytes, so that you actually set the memory for the image at the right point in that buffer. So we, again, pass some data to that. So the pixel array size, so that we know how large that is, the offset and where it should be written to, the internal handle, and of course a pointer to the renderer state. We store that off in write result. That is checked here. Again, if it fails, we bleat about it and go to texture cleanup. So if all of that is successful, then we mark success as true. This is the very last thing to happen before we actually naturally hit this label, right? So any of these, because of the go-to, we actually skip this line here and go here. And so we have this set up so that we don't have a bunch of cleanup code, sort of an if-else statements peppered all over the place. We always clean up at the end no matter what we do. But we can mark success here and then check that a little bit further down. So the first thing that we need to do is we need to release the asset. At this point, whether or not we're successful, if the asset exists, we can go ahead and release it. We don't need to hold on to it anymore. It's been uploaded to the GPU. The GPU has a copy of that data. We no longer need to hold on to that. So we can go ahead and release that. And then as far as the success goes, if we did not have a success, and I realize I could have combined this if with this one as well, but I just feel like this is a little bit easier to read, so I separated it out. So we check if we did not have a success. Okay, if we have a texture and the texture ID is not invalid IDs, meaning we got far enough into the process where we would have done some of these other things. Then we go ahead and we release the resources if the acquisition result was true, right? So we kept that up here, and we said, acquire texture resources from the renderer, right? So if that was true, meaning that part was successful, we need to actually release that because we're in an error scenario, and we don't want to leak that memory, right? So if we successfully got the memory, then, or the resources rather, then we go ahead and release those resources. And then we go ahead and we free up the entry, right? So we reset the auto releases sub TID. We reset the reference count TID to 0. And then we zero out the memory of T, right? Because we would have T because of this check. And then we set TID back to invalid ID. So this essentially just resets all the data on that, and then we set invalid ID here so that that slot is usable. And then at this point, we go ahead and return t. That being said, if we do not have success, I actually see a bug here. If we do not have success, we need to make sure that t is zeroed out, right? So we'll essentially return a null pointer at that point. And that is basically all of the events that needs to happen whenever we acquire a texture. And so this will vary a little bit whether we're loading an asset from disk, or we're loading up an asset, or instead of from an asset, we're loading up a texture from various properties that we're creating a writable texture that has width, height, and that kind of thing. This will vary a little bit, but most of the bones are here. So I hope that makes sense. Let's see. Seifel, I'm not sure what you're trying to tell me. Unfortunately, over on the YouTube side, I'm not sure what you mean by that. All right. Let's see. Should probably drink something before I continue. Okay. So from here, we actually need to think about our API a little bit more. So I was playing around with this offline, and I was thinking, well, do we really need the asynchronous versions of these? And I think the answer is still actually yes. I was thinking the answer was no, but now I'm actually thinking it might be yes. So the reason I'm thinking that is because it can take time to load a relatively large texture from disk. We could also Jobify the upload of the texture to the GPU, right? And so really those things could be asynchronous. So I think what we should do, I actually removed the type def, but I think actually, do we still have, let me see, do we actually have it over here? I don't remember if we do. K-asset on result. That's not what I want. I guess what I could do, let's just do a type def. Let's see. This will probably be a return type void. And then we'll call this pfn. Instead of resource loaded user callback, let's go with texture loaded callback. Right? So that'll be the name of that. And then the type that it will take in, or the parameters will be k texture. Texture. And I actually don't know if we need anything else. Oh, I suppose we have we can have a listener along with it. But yeah, we have okay, so we take a pointer to the texture and a listener. I think that's acceptable, right? So really we can just do acquire, and I'm going to rename this one to acquire sync, right? And this is going to be the asynchronous version. So that's going to be kind of the default is the, well, actually, should it be? Should we default to, I feel like, I guess it kind of complicates the API if we default to the asynchronous version, right? Because you'd be expected to provide a callback, although you don't have to. Yeah, let's do that. We'll stick with it. We'll stick with that. Right, so I guess, we will have two different versions of each one of these things. So the texture acquire will be our asynchronous, and texture acquire sync will be our synchronous. And then we also have, acquire from package, cube map acquire from package. I decided to separate out cube map because this is common enough where it would be annoying to have to use this one, right, and fill out this options thing. So I decided to split that one out. Also, there is another one that I added. I got thinking about this that might make it a little bit easier to deal with too if we already have the image for some reason. Say we're creating an image that, maybe we've drawn specific pixel data to or something. I don't know. If we have an image asset loaded, then we can actually go ahead and say texture acquire from image and provide a pointer to the image asset. And this would essentially perform everything that texture acquire sync does, except it doesn't have to get the asset because it already has that data, right? And then we also have texture cube map acquire from images, which takes a array of 6 pointers to images, right? Because cube maps, again, are common enough, I think it makes sense to go ahead and have that, right? So, we do have a decent number of functions here, but I think this kind of makes sense in terms of usability. Thank you for the follow. Also, Maget how's it going? Good to see you. Welcome. Hope you're doing well. Okay, so let's see. I guess the next thing to do would be we need to take this and go back to here. And we'll paste this here. Well, actually, let's do this. Let's actually take this. Right? We'll duplicate that one, and then this is actually the sync function. And so, that's the reason I didn't do that, is because I didn't have these other parameters. There we go. Okay. So, this is the synchronous version that is going to instead, essentially it's going to be very similar to this guy, except the only difference is instead of calling request image sync, we're going to just request image, right? So I think what I'm going to do for right now is I'm actually going to duplicate the code temporarily and fill this texture acquire out as it needs to be filled out. And then once we figure out how the code needs to be arranged for both versions of it, we will go ahead and split some of those out to private static methods that we can then use to eliminate the code duplication, right? So in this case, we're going to start off with this. So this code is going to be similar between the two of them. I don't think there's much of anything here that's going to change, but for now, we'll keep it as is. Let's see. So beyond that, we have the asset request. You know what? I think I'm just going to grab all of this stuff. And we'll just refactor it as necessary to make the asynchronous version of it work, right? So if it doesn't exist, we need to request the new asset to perform the upload to the GPU. So I can get rid of these guys. So we're about to solve that. And then this becomes the non-synchronous version of that. Now, this is also going to require a listener and a callback, right? So we don't actually have a listener set up yet. And so we are going to do I guess we should probably do, let me just go to here, and I'm going to copy this type def, and we're going to go up here. Let's put this here, right? Except instead of a type def, this is just going to be a static function, right? So it's not going to be a function pointer. And we're going to call this texture k-asset image loaded, and we can get rid of the word callback. So that's going to take a listener and a k-asset image, right? And we'll go ahead and fill that out in just a second. So we are going to need this function, which is going to hold a lot of our post-load logic for our asset. And then we're also going to need to type def a struct, if I can type it correctly. And this can be called texture asset load listener context. I know that's kind of long, but load listener context. There we go. It is what it is, right? So we're going to need to know the k texture, right? We're going to need a pointer to the k texture. We are going to need to know the PFN texture loaded callback, and we're going to call this user callback. And then we're going to say void pointer. And we're going to say user listener. All right. And so this is going to essentially take a copy of what is passed here and store it within this structure, along with a texture, a pointer to a texture that we're going to be updating. I think that's probably all we're going to need. But we need something to pass along to the asset system here. So let's see. Singy, how's it going? Good to see you over there on the YouTube side. I hope you're doing well. So in this case, creates listener for asset load. So what we're going to have here is we're essentially just going to do this. Right, and we'll just do listener. Let's see, what do we want to do for that actually? I guess we'll do context, right? We want this to be a pointer. So we want to do kallocate type. This will be texture asset load listener context. The memory tag. I guess we could say texture in this case. It's not really a texture though. Did we say resource? Maybe we say resource. I think that'll be fine. So we create the context. So context texture equals, we don't have t yet, right? So we're going to have to actually move this a little bit. We're going to have to move some stuff around, I guess. Or we just do this step after the fact, and we don't even worry. You know what? We don't even need to worry about this. Let's not do this now. All we really need to do is context listener equals listener. Context user callback equals callback, right? So we save those, and then this is going to be a listener and a callback, right? So the listener in this case is going to be our context, and the callback is going to be this function that we created up here. So texture k asset image loaded. We don't need all this stuff in the middle. Okay? So essentially what that means is it's going to kick off the asset system request. When that asset system returns asynchronously the loaded asset, it's going to pass along this context to this image loaded along with the loaded asset, right? So this context here will be the listener that gets passed here. So we can take that listener and we can do texture asset load listener context, and we'll just say context again, and we'll do a cold cast of texture asset load listener context from listener, right? And from there, we can actually perform, whatever user callbacks and stuff we need, right? So we'll have to fill in essentially the rest of this stuff down here. So what we can do here is if this returns a null pointer, then that means that the load of the asset failed for some reason, right? So we can go ahead and check that. We can leave this check here. All of this is fine. We don't need this goto anymore, though. We can simply return 0 here. Because we haven't actually done anything in terms of like memory allocation or anything else yet. Otherwise, this is interesting. This is an interesting conundrum. So when we're picking a free slot in the texture cache, right, we need to be able to return a pointer to a texture. So technically, we should probably do that before we do any of this. That's what I'm actually thinking. So we actually do need to pass that here. Okay, texture, right? And so instead of picking the free slot down here, which ordinarily we would do after loading the asset, but since it's asynchronous, we can't do that, right? But we still need to return the texture pointer. We'll take this and move it up here, right? So we'll pick the free slot first. And again, we don't need to go to here because we could just return 0 if we fail to find a free slot, right? Before we even request anything. So now we can say context texture equals t, right? Now this has everything it needs to be able to do the thing. So insert into the lookup tree. I feel like all of this stuff could probably be done right where it sits, right? We could probably even do it here, right? Or actually, we could do it right after we select the texture, right? So all of that can happen here. That way, while we're asynchronously loading, if we happen to request the same texture multiple times on different threads, right, like it'll be created before we actually kick off the job, right? So I think that makes sense. Although none of this stuff in here is thread safe yet, so we may actually have to think about that a little bit. I don't know if I'm going to allow for textures to be loaded from a different thread. Externally to the texture system, I mean. Let's see. Rock Derek, how's it going? Are your NeoVim config files publicly available? Yes, they are. Welcome, by the way. So right there, you'll find a link. That is to an article that I wrote about my NeoVim config. It describes all the plugins I'm using and all that good stuff. And then in there is also a link to a GitHub repo with the actual file in it. So I hope that helps. Sarah CTK, thank you for the hydrate. I did just drink something, but for the sake of it, I'll do it again. Which debugger do you use? So for right now, I am stuck using this as my debugger because it just is one of the better ones. I'm looking forward to Rad Debugger coming out for Linux, but until it does, this is what I'm using because it provides the most consistent debugging cross-platform. So this is what I'm using for right now. You know, that may wind up changing, but we'll see. So yeah, this is you know, VS, and I have to bleep it because that's a dirty word on this stream, right? Because we're NeoVim folks here. I want to keep it family friendly, right? It's bad enough I have to put this on screen, but yeah, that's what we use. I am looking into learning GDB a little bit better though, in terms of debuggers, because I'd really like to get good with that one. Because I've heard that it's pretty much like you know, once you learn Vim, you don't really want to go back. And I've heard GDB is very much the same thing. So code is a dirty word, only with VS in front of it. And I can say that because they're not together, but if you have code with a VS in front of it, it's a dirty word, you know? So if I go to put them together, I have to bleep it to say, you know, VS. You know, it's kind of like how they do censoring on TV or whatever. You can hear kind of what the word is, so you hear like the very beginning of the word, and then the rest of it gets bleeped out. That's how we roll. All right. So the next bit is, and pretty much this to do, move this to the async callback function. So everything under here needs to be moved. Right? And I'm actually going to copy that label with it, even though the label is a duplicate of the other one. Not going to worry about it. The only thing I'm not going to do is the return T, right? We'll come back to that. So if we go here to our callback function, we can get rid of the to-do. So acquisition result, if the asset exists and is loaded successfully, which is what would have happened here, request texture resources and upload the data. So in this case, we are going to need to do, oh, we don't have the name here, do we? Poop. So I think this actually requires kname. All right, so we're going to have to do that. It's only there for debugging purposes, but that's kind of important, right? So, do we have some sort of skullduggery here with our bracketry or something? Maybe, I don't know. We'll have to figure that out. What I need to do is come down here to, not there, we want the context. Context name equals name. All right. Okay, so here's the async callback, right? So this is the function that gets called back when the asset loads successfully from the async version of it, right? So, wait, no, this is not it. This is the function. Sorry, I didn't scroll up far enough. I was like, that doesn't look right. Okay, so we need context name. Then we need... let's see. We do need a pointer to the texture, but I don't want to do context texture all over the place, right? So I'm going to do k texture pointer t equals context texture, right? That'll fix a lot of the issues there. And acquisition results. Okay, so we do need to actually handle the label here, but we don't want to use this label. So we actually need to do we're going to do texture acquire callback cleanup. Right, and this is going to be that, and then we'll just replace it, right? I think there's only a couple of these in here. Yeah. All right. We also need a B8 success equals false. So similar to before with the sync version, success equals true is set only before the label. So here we can go ahead and check the acquisition result. So here, should we include the asset, the image asset name, or should we just pull from the K name to report this? I guess it's easy enough to just keep a copy of the pointer, right? So we'll just do image asset name, and then down here we'll do context image asset name equals image asset name, and then close this other buffer actually, and then up here we can do just context, oops, and back here we can do context, right? So that should handle most of that. And then we go ahead and write the data. So we request the texture resources, we'll write the data. And then once we get all the way down to the bottom here, after we do the cleanup, right, we'll say one last time if t. Then what we'll do is we'll say, let's see, context user callback, and pass context user listener, right? And did we need to actually pass the texture? I forget. I think we did. Yeah. So we'll need t as the first parameter there. Now, obviously, we'll have to do if t and user, context user callback, right? So if a user callback was set at this point, we would go ahead and make that user callback, saying, you know what, the image or the texture asset has been loaded, and the image asset's been loaded, and we've created a texture out of it, and we're done with the asynchronous process. So we call the original user callback. Call the original user callback that was passed in by the user initially. And last but not least, after we do that, we need to clean up the context. So we'll do free type, and then this is going to be, what was it? What was the context? This type here. So the type here will be that. The block is going to be context, and the memory tag, I think we said we were going to do resource for that one. So we just don't want to leak that context, right? And that is done no matter what we do. We always make sure to clean that up, right? But obviously we need to clean that up after we call the user callback with the user listener. So this is how this is going to work, right? I think it's relatively straightforward stuff. We do have some repeated code that we need to go through here and get rid of between the sync and the async version. And so we can start looking at some of that stuff. Let's see. Essentially, the only difference between texture acquire sync and texture acquire package sync from package sync is the addition of this package name right there at the end, right? So I think similar to what we did in our asset system, where we actually said, well, we can just have the the non-package version forward to the package version. Um, Maybe we can do that here, or perhaps we create a function that says, go one way or the other. Um, let's see. How do we want to? I suppose we should probably tackle that after we figure this code out first. So the order of operations here is a little bit different between sync and async. So let's see how much of that we can actually rectify, right? So in both cases, the first thing that we do is we check to see if that already exists. And if it does, we immediately return it, right? That does. I did miss an actual step here. There is a slight difference here, right? So with the synchronous version, we also have to do the callback, right? So if callback, because it's loaded, it's already loaded, but technically I think the user is still going to expect to get that callback, right? So if the callback is defined, then we'll do callback listener. And T is the first parameter there. So that's a little bit different. So I guess what we could do, let's separate this bit out into a static function that just returns T. And what we'll do, the way that we'll work this is we'll either return T if it's found, or we'll return a null pointer if it's not found. And then that'll allow us to say, if T, then we could, if T and callback, in this case, then we call callback. And then in the synchronous version, we don't have to do that bit. And I think that's probably going to be the simplest way to split these two up. So I'm actually going to take the, let's see, how do I want to do this? I'm going to take this version of it. So what we're going to do is we're going to have a static kTexture pointer, and we're going to do texture get if exists, right? And what are we going to need? I guess we could do kname name, right? And then we don't have to do that bit. So we can do all of this stuff. This, we probably don't want to do the increment reference count though, because we may need to use this for other stuff that doesn't reference count. So let's do that. Let's not do that there, rather. So image asset name. Do we use the image asset name anywhere else in here? I think we did. Right there. We could use that instead of the kname, I suppose. But the image asset name doesn't always necessarily exist. So since this is a little bit more generic and the image asset name is used to create the name of the texture, but since we're doing a texture name lookup here, let's actually use the name instead. So we'll do kname string get, and then name, right? And then we'll do the same, oops. If I can quit hitting the wrong buttons, that'd be great. So kname string get name. Okay, and then return 0 if not found. which isn't necessarily an error, right, in this case. But that means in our texture acquire, so this is the asynchronous version, we can just do this. So we can just say t is equal to texture get if exists, and then pass name, right? And then that allows us to remove this. Oops. Let's take this out of here first. Right? Actually, let's do this a little bit differently. We will do if an entry with the name exists, return it. Okay, so here we'll do t, and then we can get rid of all this and keep return t here. And then we can move this here. That's a little bit better. Index is just going to be t id. Okay, so that's better already. So next we'll have to go down to the synchronous version and make the same update. Right, so check first if an entry in the name exists. We'll see if this exists, return it. So if t, get rid of all this. And all we need to actually do here is just return t and increment TID's reference count. Okay, so that's that eliminated. So the code is similar in this case, but it's not necessarily all repeated, which is much better. The next thing is pick a free slot in the texture cache. So we are doing this first in the asynchronous version. But in the synchronous version, we don't do that until after we've acquired the asset. I think we can actually switch that up. I think we can actually reverse that safely, right? So I think we can just take this and put it up here. And now that makes this section of code extractable into something else. Let's see. So we are going to want to keep the goto. Wait a minute. Get if exists. Let me think about this for a second. Okay. So realistically, it's this section that we're going to have to extract out. Yeah, I think I'm okay with that. I think I'm all right with that. So let's take this. Which is the same thing here, right? And we could just make another small function out of it. Texture, and then we'll do texture. Get new. And I don't think we actually need to pass anything there, so just go with void. And we'll do k-texture t equals 0. We set t here. If we find it, we set the ID, and then instead of break, we do return t. Otherwise, return 0. And we can actually probably move our error condition here too. We can do that. Okay. So texture get new, we will essentially do we still are going to want that check there. Let me think about how I want to do this. So we're probably going to have to... I guess at this point, we'll just have to reset manually. I think that's fine. So let's do texture get new. We'll do t equals texture get new. And then we'll just do this here, right? If texture get new fails, then obviously this is going to not do anything. It will have already output an error message, so we don't need to do that twice. And at this point, we can just return 0 there. So we have that for the asynchronous version. And then for the synchronous version, we have essentially the same thing, but instead of returning 0, we need to do a goto on that. Okay. So that bit is separated out. The next bit about the asset request, that's just going to have to be what it is, right? Because that differs between the two versions. That's where it splits apart. That's okay. There's not really a good way for us to unify that, right? That's where they diverge. All the stuff that comes after, though, we could theoretically, maybe minus some of the cleanup stuff, we could theoretically move that out as well. Okay. I'm not sure how to read your name over on the YouTube side. I think that's Korean. Unfortunately, I can't read Korean. I just recognize it. But they say, hey, I just started the Kohi series. Thank you so much for all your videos. I really, really love them. Awesome. I'm glad you do. I'm glad you find them useful. And thanks for the feedback there. I really appreciate that. Feedback like that makes me feel much better about, all the effort that I put into this, and it makes it feel worth it. So thank you for that. All right. I guess we could. We have the insertion into the lookup tree, which theoretically we could do texture with texture get new, right? We could pass the name here. And the texture ID. Well, maybe not. Let me think about that for a second. I suppose within texture get new, we could do that. Because here we do, in the asynchronous version, we do this right here. In the synchronous version, we do that right after the asset as well. So yeah, we could probably move this too. I think that makes sense. Let's do that. Let's move that to texture get now. So we can do right before we return t, we can also insert it into the tree, right? The only thing we don't have is the name, which I suppose we could pass, right? Yeah. So we'll just modify this to take name, and then texture get new is just going to take name there and name here. And then we don't need to do this here as well. Okay. Now, as far as these default properties, these are technically the same between both of these functions, right? But these are going to differ from some of the different other API entry points. So for right now, I'm going to leave these things because these things are all configurable except for the reference count. I suppose the reference count could actually go here as well. Boom. You can also do the reference count there. So get new takes care of the reference counts. That is the acquire. Where is the acquire sync? We can get rid of this. Right, that's the same thing. Okay. As far as these properties go, and the asset acquisition, I'm probably going to leave those as they are for now. In terms of the render texture resources acquisition, I think the steps are actually the same between this. Well, let me think about this for a second. So for acquiring a texture the normal way, this is fine, right? Combining these would be fine, but there are going to be circumstances where we want to do this bit, actually all of this bit, and not this bit, right? So we should probably do this as one step, and then this is another. And I'm thinking we can actually just have them return booleans. And actually, I don't even know that this is probably not even worth extracting out to a function, actually, because it just calls a function. Same may be true for this, quite honestly. We might just leave this as it is, instead of trying to, like, split it out further. I think that's actually kind of fine like it is. I mean, yes, there's some repetitive code in here, but it is going to vary from the other entry points. So I don't know. There's only going to be 2 versions of this. Like, my feeling on, like, don't repeat yourself is take it with a grain of salt sometimes. Like, don't repeat yourself is like, I feel like if you repeat yourself once, that's fine. If you repeat yourself twice, you need to think about it. If you repeat yourself 3 times, you really need to refactor. So I think at this point, I'm going to leave this here because this is only repeated once at this point. If we have a lot of this stuff with the same properties being repeated elsewhere, then we can think about it. Okay. So I guess then we can consider both of these complete for now. I'm pretty happy with the way those have come together. So let's go to the header file. And so we have our texture acquire and acquire sync. We have acquire from package, and we need a synchronous version of that. Or I should say an asynchronous version of that, right? So technically this is going to be the synchronous version. So let's rename this one to sync. And then this one is going to take in a listener and a callback as the asynchronous version. Oops, I've bollocksed that somehow. Oh, forgot a comma. Like a dungus. All right. So this down here, acquire from package. This is actually the sync version of it, and then we have this guy, which is the async version of it. Right, and it's going to look a lot like these. In fact, it's going to look exactly like those. The only thing that it's going to call differently. Yeah, I think we are going to have to split out some of this code. So the only thing that's going to call differently is this guy, right? So instead of calling this, it's going to be from package sync, the from package sync version of this. That's literally going to be the only difference. So probably what I might do, should I have one call the other? Or do I... Maybe I should extract these and just parameterize the package name. Yeah, I think I'm going to go that second route. So what we'll do is we'll take this and we're going to put it here. And we're going to do static. And we're going to do acquire sync internal, right? And we're going to do const character array package name, right? And what we'll do, since the only version of this, or the only thing that really changes here, we're going to do, first off, we're going to do asset equals 0. Oops, equals 0. And then here we'll say if not, well, actually, if package name, right? So if we have a package name, we'll go one way. Otherwise, we will go this way. And then we'll say asset equals this, right? And then here, we could just copy pasta this, do this, from package sync, passing in package name, right? Then, all we have to do is take all of this crap, nuke it, and return texture acquire sync internal image asset name null as the package name. And then when we do this call down here, we do the same thing, but we pass package name instead. Thus, we do not repeat ourselves. Let's see. Still using C, saw your post on giving it up. Yeah, that was an April Fool's joke. I think you're talking about, let me find it. You know what? Let me actually pull it up on Twitter. Give me a second, because that's displayed a little bit more obvious there. Let's see, where is it? Here it goes. Okay. I'll move this over here. Yeah. So I'm assuming you're talking about this post here, where, you know, I've tried over the last few years to do things the right way, from scratch, in C, using Vulkan. Come to the conclusion that's just too hard. Not giving up, though. Going to port the Kohi game engine to TypeScript WebGL and embrace the inevitability that is OOP. Yeah. Note the post date. It was an April Fool's joke. Yeah, so I was totally kidding with this one. Yeah. We might actually circle back to a TypeScript engine at some point, because that's where this channel actually got its start. But yeah, no, we're not actually doing that. Yeah. I just kind of silently posted this and then just left it there. But yeah, that was definitely an April Fool's. And while I'm at it, some people might appreciate this one too. When it comes to vibe coding, all I can think is vibe is violently improvised, barely engineered. Just sat there and thought of an acronym one day of what vibe could mean for vibe programming. Spiro should appreciate that one. Anyway. Yeah, so we're not gonna be switching away from C. If I were to switch away from C for anything, it would probably be to C++. Even though I don't really want to do that, but if we ever had to switch away from C for some reason, that's what I'd be switching to. Okay. And there's only like a couple of reasons why I would ever actually switch to C++, so you don't really have to worry about that either. Okay, so acquire sync is done. Acquire async is going to essentially be this guy here. So this is texture acquire, right? So what we'll do here, I think I just took a copy of the function, yeah. So we'll take a copy of this guy, do static, texture acquire. I'm going to call this async internal, right? Just to kind of mark it as exactly what we're doing. So this function is fine as it is, but that also means that I can take all of this rubbish in here, and I can just do return texture acquire async internal image asset name listener and callback, and just return that. And then take a copy of this one. Oh, I need to change something real quick. We need to add package name here, and change this as well, right? So similar to how we did it elsewhere, if package name, then we do that route, else if no package name, then we just do that, right? And then we just do assets equals this, and then request image, asset system, request image from package, right? And this is just going to actually require package name there, okay? So that is that. And this just needs 0 for the package name. Let me make sure I got that parameter correct. I think I did. Yep. All right. And then we can take this one, and we'll have our acquire from package down here. And we can paste that, and just replace this with package name. Boom. Done. All right. So the next thing I want to do is we've got all these static functions kind of mixed in here with our sort of public API functions, and I kind of want to not do that. So let's stop for a second and kind of reorganize this a little bit. So typically what I do is I like to have all of my sort of public API functions at the top, and then try to bump all the static stuff down to the bottom, which is fine, but that means you typically have to forward declare the static functions before you can do that. The other thing is I'm going to take this listener structure and put it up here as well. So we'll put that up here. And we will take this, let's start with this image loaded one, right? We'll take this, and we already have like some old stuff here, which is all going to wind up going away. And probably all of this as well. So what I'm going to do is we're going to say to do remove old functions. And then we'll do note new functions. How did I miss the double slash there? All right. And so we'll paste this, turn it into a forward declaration, and then go here. Select the whole dang thing, go all the way to the bottom, We're also going to do a note new there and paste, right? Because we are eventually going to get rid of these old functions that used sort of the old way of handling textures. All right, so we've got that. We want texture get if exists. So let's take a copy of that. And then we'll put that here. Get if exists. Take that. Down to the bottom. Back up here. I think we actually have a couple in a row here. So what I'm actually going to do is I'm going to go here, take this one and this one, cut them, go down to the bottom. I'm going to paste these, and then I'm going to grab this one, go to the end and grab just the first line of this one, go up here, back to the top, put this, and then do delete inside brackets. Did that? Yes, it did work. Okay, perfect. So we'll just do that, and then change this to a semicolon. All right, so we have that, and then let's see, where is, here we go, acquire sync internal. So we'll take, let's just take this one, go to the bottom and paste it, and then we'll grab this, go to the top, and put that here. All right, now we've got all of our sort of public-facing functions here, and they're all together and easy to sort of decipher what's going on. So that's going to be the kind of pattern that we follow, is we're just going to kind of try to split out some of these things into, these internal functions so that we don't wind up repeating ourselves a bunch of times. Just make it a little bit easier to kind of navigate the code. Okay. So I guess the next thing that we need to do, I wonder if we should think about release first. I kind of think we should, because it's going to be relatively the same process for any texture. Let's do that. Right, so we want texture. I think what we can do, I don't remember if texture resources release, right? So we have a state pointer, renderer, and then the handle is going to be the address of texture, renderer texture handle. I don't remember if that handle is invalid. If that is actually handled by the renderer. It should be. So I'm going to say if texture and texture ID, ID is not equal to invalid ID. I think actually all we need to do, we need to release the resources. So that will free up all the memory on the GPU. And then, yeah, I think the only other thing is to clean up the actual texture struct itself. Which really just amounts to invalidating the entry, right? So we can actually do let's see, we need to do state pointer reference counts, and then we'll do sub TID, texture ID rather. And we'll reset that to 0. We'll do state pointer auto releases, texture ID, equals false. Now, this is only done, or I should say actually this bit should only be done if we're actually going to reduce our reference counter to 0. Right, so I guess technically this isn't needed, right? So I guess let's do U32 counts equals this. Right, we'll get rid of the 0 for a second. Well, actually, I guess, let me see. How do I want to handle this? I guess we can let's just actually use this, because if I take a copy of it, that's going to make things weird. So if this is greater than 0, right? Then we're going to take this and decrement it, right? And then what we'll do is we'll actually do this. Take a copy of this, and this time we'll say if it equals 0, then we need to do this stuff. But that's also only if the reference count equals 0 and auto releases texture ID equals true, right? So we only want to do this if auto release is actually enabled for that particular texture, right? Otherwise, the ref counter will essentially reach 0, right? But you won't unload the texture. So that could be useful for something that's something you might not want to like auto release is like a font texture, for example. So you're going to have UI elements maybe getting loaded and unloaded, or created and destroyed and things like that. And so there may be instances where you destroy all the UI things and maybe a particular font texture is no longer actually referenced. But the next time you pop open a window, you don't necessarily have to have to reload that font texture. So instead of doing that, you could set auto release to false, and that would actually prevent this from happening even when this reaches 0. Thank you for the follow. I appreciate that. Welcome. Hope you're doing well tonight. So I guess what we could do, technically speaking, this should all be encapsulated under this, right? Because if our texture reference count is 0, we don't want to do anything, right? Technically, in this case, we should probably actually throw some sort of warning to say, hey, you're releasing a texture that has no references, right? What are you doing? Texture, and I guess we'll throw out the name, has no references and cannot be released. And then we'll do texture, oh shoot, we don't have the name for this, do we? Ooh, that's an interesting idea. That's an interesting problem. So we have a lookup to go from name to texture, but we don't have a lookup to go from texture to name. How am I going to handle that without storing the name on the texture itself? I mean, the only reason I need this is for like debugging purposes, right? So I guess I guess I could do texture ID here instead, right? And we could maybe look that up somehow. Texture ID. So we might need to think about that. But the rest of this, I think, makes sense, right? So if we have a ref count over 0, we decrement it. If that ref count hits 0 and it's set to auto release, then we actually do the auto release, which is all this stuff. This also frees up the slot, so we actually need to do one more thing. So K0 memory, we want to do texture, size of K texture, but then we want to set texture ID equals invalid ID, right? So that'll actually make the slot available again. Okay, I think we've covered everything there. I think that's all we need to do for texture releasing. All right, let's see. Where are we in terms of time? We have a little bit of time left. So I guess we should probably look at we should probably take a look at maybe some of these other things, right? Like acquire from image, acquire from images. Or should we fill out the cube map stuff first? Maybe we should do cube map first. Or acquire with options. Which acquire with options, I don't remember, did the options actually have, I think we took out synchronous out of this, but yeah, we did. We probably need to have 2 versions of this as well. So we'll just rename this one to sync, and then this one we'll need to do void context, or no, it's listener in this case. And then texture loaded callback. Let's take this, go here. Right, and then we'll do this one is renamed to sync. This one kind of makes me, I mean, the more I think about this, the more that some of these internal ones, these might all actually wind up pointing to this one. Now that I think about it. That might actually be the better way to do it, right? Like maybe we have the more I think about it, the more that actually kind of makes sense, because then we can put all the logic in one spot. This is the most configurable option. So we can essentially create configurations in these guys and just pass it through to this guy, which I think will still be readable enough. It's not quite a one-liner here, but I think that's okay. So maybe we don't even need these internal functions then, thinking about it. Right, the internal functions just become this guy. And then we just deal with the options accordingly. The only thing that I see here that's going to be a problem with this is we need to think about acquire from images is not going to be able to pass through to that unless we actually add like an image count here or something. Right, so this is acquiring from an image asset. This is acquiring from 6 image assets. If we do a layered version of this, then it'll be essentially the same thing, but like any number of these instead of a hard-coded 6. But since this is a cube map, hard-coded 6 makes sense. So I think we might... Because the way that cube map acquisition works is a little bit different from the way that regular acquisition works. So for texture acquire, we have an image asset name, right? For cube map acquire, we have an image asset name prefix. So this kind of follows the old sort of texture system thing in here. Let me find it. Here. So where we had this texture system request cube, we had this sort of base name, right? And then whatever that base name is, we essentially build 6 strings out of it and load those 6 assets, right? So front, back, up, down, right, and left. And so this function automatically kind of did that for us. And so I guess what we could do, we'd still generate those. I think that still makes sense. We can also set the texture type in here, right? So if it's a cube map, we can set that in here and let's see. We should probably have image asset name separate in here, right? So yeah, I think this is the way we're going to do it. So if we're dealing with a cube map, the image asset name is going to be the prefix, going to be treated as the prefix. Otherwise, it's just treated as the entire asset name. The name itself is to be used for naming the actual texture. So if we had a situation where we wanted the texture to be named something else other than the image asset name, which is the default, then we could specify that here. So if this exists, then the name of the texture will be this. Otherwise, it will fall back to this. Okay. All right, this covers everything except... This covers everything except these guys. Right, the acquire from image and the acquire from images. And I don't know that we necessarily need those. I just think it might be a little bit nice to have them. So maybe we just don't even do those. Maybe we just avoid this, right? I'll comment it out for now. And if we want to do that in the future, we could always add some sort of option in here for it. I think that makes sense. So Kellis Music, how's it going? How are you doing? It's good to see you. Let's see. Got some comments over on the YouTube side too. Souvenir Software, how's it going? Let's see. I have a question. Which Linux distro do you develop? I am working on Arch Linux at the moment, by the way. I've used Ubuntu in the past, but I switched to Arch 3-ish years ago and never looked back. Sorry for the silly question, but I'm guessing the reference count isn't atomic. Will textures never be shared between threads? So yeah, we were talking about that before. So none of this stuff is thread safe yet. However, the only part of it that needs to be thread safe, realistically speaking, is let's see, where is it? Oh, we're in the H file. is this. Everything here. This is the only stuff that... So, essentially, I mean, I could use a mutex or something to guarantee that, right? And we already have all the acquisition code in one spot for all of this stuff. So it wouldn't be very hard to make that thread safe. We just haven't yet. It's not a silly question, though. Not a silly question at all. Are we going to be requesting textures from multiple threads? I don't think so. I don't think there's really a need to do that, because we actually have a job system that we're going to leverage in terms of loading the texture asset load from disk, which is the slowest part of it. We already have like an asynchronous setup to do that, and all that stuff is thread safe. So it's basically like we request a texture asynchronously. We reserve that texture out of the textures array that we have here, so that we can immediately return a pointer even though the thing isn't loaded. And then we kick off essentially a job on another thread that says, hey, load the asset from disk. When you do that, when you're done doing that, come back and upload its data to the GPU, and all that stuff. And at that point, none of that stuff has to be thread safe at all. We should be good to go on that. The only thing that we might have is the only thing I haven't figured out yet is whether or not we ought to have some sort of flag on the texture that says whether or not it's loaded. But the upload to the GPU right now is actually synchronous. So, and I don't know if I'm going to, for the game we're making, I don't know if I need to make it asynchronous. Our renderer isn't multi-threaded right now. It's built in a way where it can be, but it isn't right now. So it's a long answer for a non-silly question. Let's see. You wrote all your own containers for Kohi. Yes, I did. Was perusing through the Kohi repo the other day. Yeah, we have all of our own containers. Yep, we wrote them all from scratch. We write them as we need them. That was part of building the whole infrastructure for the engine. Went through all that fun stuff. Would love to be able to do that kind of stuff. It just takes practice, right? It's not particularly hard. It just takes practice. You'll learn it. The more you do it, the more you'll learn about it. The only thing that is even a little bit complicated, and that's because it relies on some macro magic, and it's not, I say complicated, it's not really all that complicated, but the only thing that got a little crazy was the dynamic arrays because of typing and stuff like that. But you could do it without macro magic too. It's just I used macros heavily in that so that you don't necessarily have to worry about typing information all over the place. Yeah, so one thing that I would do if I were you, if you're struggling with making container types of things, I would probably just make a separate repo with that and just do a little bit of research on how they're supposed to work. And I would recommend try to find something that explains it visually, how they're supposed to work, and then implement it without looking up any source code, right? And see if you can actually do that. Work your way, reason through the problem, reason through the data, and see if you can actually figure it out from scratch. What's the game called again? So it's Shadows of Illumina. Yeah. I think I put that... Did I remember to put that in the title? No, because we're doing a game engine stream tonight. Yeah. Working with a linked list is a nice way to get started with that. Yep, linked list is good. Dynamic array is good. Your simple ones like a stack is good. A queue, all that stuff. There's one video lecture I've watched on repeat about buffers that goes through all the concepts. Perfect. Yeah. So see if you can find something that's See if you can find something that's like generic and kind of explains it visually, and then try to implement the code on your own without looking up source. I thought you said you renamed it. I did. Well, I renamed the project. Yeah. So it doesn't say SOI all over the place. It's just the project's just called Illumina now. But the actual official title of the game is Shadows of Illumina. Yeah. How's it going, by the way, Soulfoam? It's good to see you. Where was I? So I'm actually thinking now we should probably relocate what's in these internal functions into options sync and options async, for lack of a better term. And then just sort of pick apart the options and do whatever we need to do based on those. So I think I'm going to do, let's do the synchronous version first. So I guess we'll do this one. So I'm just going to take all of this stuff and I'm just going to copy it for now. And we'll go back and remove the copies later if this works out the way that I'm thinking it's going to. So we'll put this in here. All right, so the name is going to be, so if we use object name, or options name, then if we have options name rather, we'll use that. Otherwise, we'll use, actually, I don't even need to do it this way. It's kind of stupid to do it this way. Let's actually just do, let's see, options name, otherwise options image asset name. Okay, so that's the name. Texture get if exists. Okay, so that's going to do a lookup by name. That is fine. So if we have that, it's just going to increment the internal reference count and return. So that works. Pick a free slots. This should not need to change either. The asset request, however, will need to change because we need to only request this if we are actually loading an asset for the particular texture. And there's going to be a few flags that we can check to see if that's the case, right? So we have, oh, now that I think about it though, we actually need to do a quick couple of checks on the options here to verify that some things are valid, right? So if not options name and not options image asset name, right? We need one or the other. So we'll do either name or image asset, asset name is required. Yeah, I think we just leave it at that. And then do function. And then return 0. Right? So we need one or the other of those, right, in order to generate a name. If both of them are null, then that's kind of stupid, right? We should probably also check the, I guess, the string length of both of those. let's see. I guess we should do, let's wrap this and we'll say if not options name or string length options name, right? So if that is also 0. So if we don't have a name or we have a 0 length string and we also don't have a image asset name or that name is a 0 length string, then we bleat about it. Otherwise we can use it. Nivimi, how's it going? Long time no see, I feel like. I feel like it's been a bit since I've seen you on stream. How have you been? Makes more sense. I miss soy now. Yeah. Yeah, we don't do any more soy on here. SOI, right? We don't do any more of that. You made me change it, cell phone. You had an impact there. Alright. So I guess the next part of this is going to be if we have an image asset name, then we need to load an asset, right? So I guess there's a few things we probably need to figure out before we actually even go any further, right? We probably ought to do... I guess we can look at that first. So we'll say if options image asset name, then we do this stuff, right? And then if options package name, then we go this route, right? Let me get rid of this. So if it doesn't exist, we need to request the asset, right? Now, this is going to be the path that we're going to follow if we have a single asset, right? Which means that it means one of two things. There's a couple things at play here. So the first thing we need to say is if options dot, let's see, I guess we want to use type. We'll probably go by type, right? So we'll say texture or k texture type. So we want if it's a do we need a cube? So essentially we have to handle the types of 2D array, cube, and cube array a little bit separately, right? So I guess let's do cube first, right? So we'll do to do load, we'll say treat the image asset name as a prefix and load the required 6 images, right? And then we'll say else if options type equals k texture type. Let's do 2D array, right? To do need a way to load multiple assets into layers in config. Loading will be handled similarly to cube maps. All right, so that's kind of the other exception case, and then the most common case is actually going to be just this guy here, which is single asset, right? So if we have an asset name, we may or may not be loading an asset, right? This is going to be load a single asset to for the texture, right? This is going to be options, image asset name, options, package name. Same thing here, same thing here. All right, so we are going to have to handle these two guys a little bit separately, and that's okay. Let's see. So this format, do we actually define format here? We do. Okay. So this is actually just going to be options format, options type, options layer count. I wonder if we should technically speaking, the only time that that should ever be used is here. This should be TArray size equals 6, and then this should be TArray size equals 1. T dot flags equals options. Do we not have flags? I guess we don't have flags. Oh, right. I'm going to have to actually look at... I'm going to have to set the flags individually based on the option boolean. Automod got you, yeah. Yeah, I don't think I'm going to let that one through, cell phone. Semi-family friendly through here, you know. We drop we drop some verbiage every once in a while, but... Diamond, how's it going? Good to see you. You're streaking 5 times in a row, actually. Fine, I was just busy a bit. Okay. Well, it's good to see you, NivyMe. I totally get being busy. Believe me. All right. So let's give ourselves some notes here. Parse flags from options booleans. This is going to be options. Let's see, did we actually have auto release in here? We did. Okay. And I actually just thought about yeah, that's fine. Okay. So I guess we need to figure out width and height and MIP levels and format and all that good stuff, right? So we probably ought to do... That's all going to be based off of whether or not we're actually loading an asset, right? So if we're loading an asset, then we can get it from that. If we're not loading an asset, then we need to go by the configuration, right? So I guess we can do... Let's default. We'll say equals options width U32 height equals options dot height, and then we can come down here and say if we have assets being loaded, you know, we can do width equals asset width, height equals asset height, and then down here we can just use that. We also have MIP levels, right? So we have, what is that, a U8, I think? So we can do U32 or U8 MIP levels equals options. Do we not have MIP levels in here? I guess we can, all right, I guess we'll just default that to 1. And then we can do MIP levels equals that. And then here we can do just MIP levels. Okay. So we'll finish all of this stuff, I guess, on the next stream because we're pretty much out of time for tonight. Unfortunately, I do have to get up and work in the morning, so it is what it is, unfortunately. Diamond, I know you just got here, but yeah, unfortunately we are out of time. So I really appreciate you guys being here. We did make some decent progress tonight, at least, so that's good. Let me find somebody to raid. You know what? We're gonna raid because he's not been on yet. I've actually joined a new stream team recently, and so we're actually gonna raid the leader of that stream team, who's Felonier. So we're gonna see what he's up to, and yeah, that's gonna do it for the stream tonight. Thank you guys so much for being here, and yeah, I will catch you guys on the next one. See ya.